I'm Brian Whipker at NC State University. So with the PGR overdoses, sometimes you overregulate. You need to come back with some options to try to salvage that crop. But other times when you're looking at things, there's other mimics there. There's a lot of things going along with greenhouse production, and they kind of look the same. So we're going to go over some of those mimics to help you diagnose the difference between what's really occurring and hopefully be able to salvage that crop. So again, it's recognizing PGR overdoses. Do want to thank Fine Americas for sponsoring the webinar and making it possible. They're also sponsored a number of the research projects that are highlighted here. They had nothing to do with all the mimics, though. Those weren't PGR induced. So when you're looking at different aspects, what we're going to talk about today is recognizing first PGR overdose symptoms. Then number two, enhancing plant growth. And then by far, we're going to talk about the mimics of distorted growth to help you diagnose those situations. So when you look at PGRs, they are excellent tools for managing excessive growth. And so if you get the rate right, it's great. If it's too high, then you're going to get stunning. So the question is, how do you recognize the overdoses? And then what do you do about it if you overdose it? So we're going to talk about that aspect. So getting the rate right, there's a number of guides. The new PGR perennial guide, Joyce Latimer came out with Fine Americas and Grower Talks, just came out this month. We have the annual one there. It's at the bottom. And of course, the PGR Mixmaster that Brian Krug worked on, it's available from the e-GRO.org website under the mobile app icon. You can access it there for getting the mixing right. And when you do mix right, you get nice, even control. That's what we want, consistent results, as you see here with the pansies. So with optimal rates, you do control that stretch like the osteospermum that's on the right, or you can, and they'll be proportional to pot size. You get tighter spacing on those benches so you can get more production per unit area. And you also, with the sunflowers, see the plant on the right with a darker green color. You get the enhancement of chlorophyll. Two factors. One is an uptick of chlorophyll. The other one is that the leaves are more less spread out, so the chlorophyll is more condensed. That helps you get more green color. So all positive attributes for what you want out of a PGR. But sometimes things can get a little high. And if you get too much growth control, you can get stunted plants. You might not get leaf expansion. Flowering on some PGRs can be delayed or the size is smaller. And if you nailed it too far, it's really kind of hard to establish some of those plants in the landscape. So those are all things we would like to avoid with some PGRs. And so you can see here, this is from last spring. I was at a grower, and what happened? These plugs that were shipped, you can see a difference. The bottom, basically at the 6 o'clock position, they're really gnarly and stunted, whereas the top of the plug flat, they look okay. So what happened? Well, it was overspray from a targeted crop to this non-targeted set of begonias, because begonias are more sensitive to the problem. So those plants that are overdosed are going to be problematic, and it's going to be very much of a challenge to get them to grow out. You can see more up close, there was more than one flat that actually got nailed in this situation. So those begonias are going to have some encouragement to make them actually make a crop. Here is an excessive drench application on moms. You can see that tight growth that's occurring. This one actually grew out pretty well because the flowers went ahead and opened and covered it up, and overall things look pretty nice on that one. The same thing here for an excess spray application on this set of garden mums at a different operation. On retail, there's some photographs I took this past year. Look at those leaves at the top, the ones that are gnarly and kind of crinkled. That is classical PGR application overdose. Too high of a rate, nailing it. The consumer's not going to be as happy with that because they're not going to grow out. The same thing, look at the dahlias, especially about in the 6 o'clock and 3 o'clock orientation on that dahlia plant, though it's overregulated. It's not going to be quite as nice unless it gets in the landscapes and starts growing out. And then here's a lobelia. You can see that it's been nailed quite a bit, and you got that shorter overdose or shorter internode. So these are all symptomology of PGR overdose. The same thing here. It was an overdose on a drench, the plant on the right, compared to good control that occurred on the plant on the left. So that one was nice and compact of what we actually wanted to see. So we've seen what the symptomology looks like. How can we go about then increasing that type of plant growth? And so it's frustrating when you see that plant being stalled. How do you get it to grow out again is really what we're going to focus on in this part of the presentation. So there's a lot of factors that can stall growth. You also have insufficient fertilizer rates, suboptimal temperatures, cloudy weather, and PGR overdoses. So you can affect PGR overdoses with adding another growth regulator. Some of the other ones, if you don't really fix the root cause, you're going to limit the amount of growth that actually you can encourage. So how do we go about doing that? There is a product out there that is Fresco or Fascination that is a combination of 6BA and GA4 plus 7. So it works very well. Growers are using it to help encourage growth if you need a little more, or overcoming a PGR overdose. So when you're looking at the product, they can be applied as a foliar spray, a substrate drench, or by chemigation. But do note that only Fresco has a label rate. So it's Fascination doesn't have a label. And so when you're looking at target rates for a spray, it's 1 to 5 part per million, and it's also 1 to 5 part per million that you target for a drench. And so if you're using it for the first time, use the lower rate, make an application, wait 7 days, see if you get a little growth, and if not, you can come back in. It's a good idea to use half the rate you used the first time, just to try to stimulate that growth. Because if you do too high of a rate and you get too much growth, you're going to have to come back in with another plant growth regulator to slow it down for what's happening there. And so what the idea is applying enough to overcome the effect, but not too much to make it go ahead and shoot up. And so again, a small trial using the 1 to 5 part per million. A lot of people are using 2.5 to 3 when they're playing around with it. There will be some cultivar variation there. And also, if it is a PGR overdose, depending on how much you actually have nailed that plant, how much it's the art of overcoming it. It's not the science. You got the parameters. You're going to have to play with what needs to go on with those plants. So what kind of effect do you expect to have? Here's some plants from a study that we did looking at, well, it was a side, this is the side part. These were the untreated control. So look, Fresco was applied at 0 up to 6 parts per million. And you can see based on that red line, how much growth enhancement that you got. So the 6 part per million, and that was applied twice. All those PGRs were applied twice. You can see a more bigger, robust plant. So here's the case of stimulating overall growth when there is not a PGR overdose. So from that standpoint, it's just growth enhancement, not a PGR overdose situation. But overcoming a PGR overdose can be seen here. In this study, we intentionally overdosed the plants with paclobutrazol. And we applied 8 part per million on these New Guineas. And that's a high rate. We nailed them. And you can see the degree of nailing on the plant on the left. And you can see that it's not much flowering going on at this point. And so it's smaller, more compact. But look at the red line that goes across. Look at the plant diameter that's been enhanced. So we're looking at then going about after the initial application where we nailed it, you can physically see that we nailed the plants. We then came back with a follow-up application of a Fresco spray. And you can see the amount of growth enhancement, both in flowering, because look at the 2.5 part per million. You got some good flower power compared to the one that did not get any Fresco versus a bigger size plant. Frankly, at the 10 part per million, I'm a little surprised they look that good. Sometimes you can get some excess stretching. I get nervous recommending 10 part per million. So I don't know if I would actually do that. I would be targeting the 2.5 to 5 is where I would be going. But you basically could see here, you recovered a plant, a crop that had been overdosed. So it works very well for overcoming that with a fresco application. Now, you can't have too much growth. You can see that growth stimulation there in the plant in the box. That's just too high of a rate they were playing with. You get that peduncle, that stretch going on there. The plant looked pretty good, but it's weaker. Will it make it in shipping? Will the cart have to have the shelves moved up a little? So that's too high of a rate for what they have. Also, here's a rate that was high on begonias. You got more of a stretch, a yellowing of the top growth of the plant. That happens if you go too high of a rate. Now, here's a case this fall, and this is, I love the photograph. So what happened is they were making their concentrate to put it through the boom. So, they want 3 part per million, but it's being applied 1 to 100. So what is it? It's 300 part per million fresco here. And so they spilled some out of the concentration bucket when mixing it on about 4 plants there on the side, because you can see the rest of them are okay. I can tell you it works. You can see that 300 part per million, you don't want bracts quite that big, so that might not be what you're targeting, but you can see some of the effects that went on. And I have seen a crop where a rate was mixed up. It's basically just the GA, and the entire crop looked that way, and that was not a good thing to see. So you can see the effect that goes on. So additional tips here. So it will help overcome some PGR overdoses by using a fresco application. If you add too much, what do? You have to come back in with another chemical to stop that growth, like a Piccolo 10XC or a Dazide or another product. So you can go back and forth. It's not optimal, but you can play with pumping the gas, hitting the brakes, pumping the gas, hitting the brakes. There is an option there to a certain extent for what has to happen. So on poinsettias, we have found that, especially later on, that drenches are better than most foliar sprays, primarily to avoid some bleaching and some distorted growth. That bleaching or greening that happens on those plants are not optimal. And again, only Fresco has the drench label. So what do I mean by greening? Here's a crop where they did a few applications of foliar applications to the crop to try to get some size up, and the applications for later. And you can see the green overall effect on the pink variety on the left and also on the red variety on the right. And so that's kind of hard to overcome at the end of getting a real robust coloration going on. So you can't make weekly applications. That's not actually a good thing for the plant. So again, if you're looking at Fresco fascination, foliar sprays work, Fresco drenches work, and so just make sure that you have sufficient time that you can stimulate that growth. And again, on a poinsettia that's set a terminal bud, you can only play with those nodes of stretching, that inner node stretch. You're not adding any additional nodes on there. So there is a limitation to how far you can go to get the results that you want. So at this point, I'm going to shift gears of looking at mimics of distorted growth. So I have a number of slides here to go through to look at some of the other problems that, while you may think it's a PGR overdose, it's other things. And so we're going to look at some of those options that are out there. So when you're looking at this type of abiotic disorders, non-living disorders, 3 key steps to keep in mind for the diagnostic process. Know what disorders are potential, what information do you need to collect, and then to go through on problem solving. You really don't want to shoot from the hip. So the disorders that are common, here's a graphic that I made looking at some of the most common. There's a few other ones that are out there. Type of situations that give you distorted growth. The middle part of the band is the more common situations that happen 80% of the time. The bottom row is probably 20% of the time. So just looking at some of the disorders, and we're going to go through each one of these. So when you're diagnosing a problem, a lot of them look the same. An incorrect diagnosis doesn't do anybody a favor. So you collect some data to make sure you're making the right diagnosis, or send it off to a diagnostic lab. So it improves the accuracy of getting it right and being able to salvage the crop. The crop information that you need is, there's some key information: what was applied, the type of symptomology, where's the location on the plant, is it the oldest, middle, or youngest leaves? That tells you a lot of what type of problem it could be. You know, it doesn't hurt having a pH and EC value just to see if it's being grown right. It's kind of like taking the blood pressure and your pulse of the plant. And then, you know, looking at the roots. Good roots make good shoots. Without a good root system, you're not going to have good growth. And then the type of pattern that you have, and the percentage of the crop that's affected. Some things are scattered, other things can be the entire crop, and that's helps on diagnosing the situation that's going on. And so now we're going to start going through the process of problem solving. So for distorted growth, we're going to key in on these primary factors one at a time. So with the first one we're going to look at is calcium deficiency. And what you see is that it occurs on the growing tip. And so here on this Dusty Miller, it's distorted small growth. And again, usually we see most of that growth problem occur when the leaves finishing the last half of the elongation. You can see it here starting to come in on the eggplant, and you get that leaf curl. And so we're starting to see some death of the cells along the outside diameter, or the margin of the leaf. And with those leaves slowing down on development and the interior still working, the leaf starts to give you that cup look that you're seeing there. And so calcium, again, it comes in on the plants when the leaf, usually initially when the leaves are finishing that last 50% of expansion. pH will affect availability. Too acidic, it's harder, but most of the cases, higher levels of calcium are available if you're over alkalinity. And so you know, there is the lack of calcium, and then there's some cases when there's cloudy weather, you don't have transpiration of calcium up in the plant, and you run into problems. Here's the tip problem again on the lettuce. You have the death occurring there with that leaf necrosis. It stops growing, the rest of the leaf keeps on expanding, and you get that type of curl happening on that plant. And you can also have it on internal situations, such as this cabbage plant where we induced it and we got a real pretty effect. You know, for taking photographs, that was a nice shot, but for a grower, that's not what you want. So the next thing up is very closely related, is boron deficiency. We see this quite a bit, that you see the lack of the meristem, you see thickening of those shoots. If you fill the plant, it feels thicker, but a real strong PGR overdose will give you the same thing on that plant. And so you do see those axillary shoots because you lose that growing tip. The secondary ones come out. You know, most plants, when you're looking at it, it's usually scattered that it might happen, like if it was a problem with the plugs. You know, look at the pH in this one. The pH was okay, the EC was okay, and they were doing fertility, and there's no other PGRs that were applied. So it helped in the process of going through and diagnosing the problem. And again, if you grab that leaf, it's thicker, and sometimes you can get them to crunch. They actually break up into little bits. It's really kind of a cool effect. We induce the problem in a system we have, so we see it quite a bit for what's going on. Now, one thing I want to caution you on, that we did some tissue analysis, that look down there at the green circle boron. So boron, in the case of this lab analysis, of 28.3 parts per million, and it came back as being sufficient. And so you don't always pick up a boron deficiency with a tissue analysis to help you confirm it, especially if it's a point in time an environmental induced deficiency. It's just not getting the boron in the exact growing tip where it needs, even though it might be in the rest of the leaf. So it doesn't always work with tissue analysis to confirm a boron deficiency. What do? Discarding is probably best. It's really hard to overcome that. Neither of those plants are economically going to be cut back and regrowth. You might as well go ahead and ditch them. But a lot of times it's just going to be scattered ones in the crop anyway, so you're better off chucking them in the first place. So the next one up is broad mites. in the case here, it's normal growth at the interior of the plant, and then the new growth is distorted, and that's because the broad mite population increased. And so it might be more severe further out there, but usually it takes a time for it to build, and in pots, you'll see the old growth being okay in most cases. And so in this case, 100% of the plants were affected, but they were all from the same stock plants, and they were all put on the same row. Now, they were like 4 months old. No other plants had the symptomology. And we did the pH and EC test, and the fertility was good. So it was not the case of anything with nutrition, which kind of helped us say it wasn't calcium boron. So again, a very distinctive cutoff of new versus old. Of basically what happened is the broad mite population built up, and you see the damage going on. So how do you diagnose this? 100x microscope, and the eggs are the better diagnostic key. They're oval, and those white dots on it will help tell you that it's a broad mite. Without those white dots, it could be a cyclamen mite, for instance, but they're still, you'll see the adults. I mean, you probably don't care which one it is, you just know that's the problem. So 100x microscope really comes in handy to figuring out that problem. We did cover it in 217 e-GRO. It's kind of hard to cut them back and have them regrowth. You're usually going to have to end up chucking it, but you might go through and do an application for mite control and turn it around. But in many cases, it's just too difficult for what's going on. The fourth problem, 2,4-D, we had this problem going on. The new growth is normal. The old growth is normal. The new growth, you can see the curling that's going on, the new growth there. Usually when you have drift of 2,4-D, there's quite a bit of the crop affected, and there's a higher percentage that occurs closer to the air intake of the greenhouse. It's basically vapor drift. The pH and EC in this one turned out to be okay, but you can see that curling that's going on. And you also, under severe cases, can see that you have kind of distorted growth on the base of the plant in those secondary shoots. Because what's 2,4-D do? It grows the plant to death, so that's why you're having the axillary shoots. And here's the top growth going on also with that plant. What do? Really, it's kind of hard to salvage them and cutting them back. So you might decide the best option is also to discard these plants. So the fifth one is thrips. You grow thrips, you can see the distorted growth in that plant, the ipomia there. If it's heavy infestation, you get curling going on. You look for the cigar-shaped symptoms, or the insects, either the larva, which if it's the larva, they're usually more of a creamy orange, versus the adult, which is kind of a little brown that you can see. Just get a white piece of paper, knock the leaf on it, and you can visually see them to help you on the diagnosis. But thrips are common enough. I think you know probably how to do the diagnosis of that one. The sixth problem, looking at more uncommon situations, aphids. At high levels, you can see the distorted growth occurring, but how you diagnose it, turn the leaf over and you can see what's going on. You'll see the sooty mold on the other leaves. You can see the cat skins on there. That's a pretty easy one to go through and diagnose. The next one, we talk PGR overdose. You have the stunted growth, the flowering's delayed. Look at your PGR records. If you apply to PGR throughout the greenhouse, it's probably going to be the entire crop that got affected, or one cultivar. And so you can go through and do the diagnosis. It's going to be hard when you touch it, very similar at these higher levels as you would expect with the boron deficiency. But boron's going to be probably more of a scattered set of plants to help you diagnose between the two. Distorted growth on number 8, high light. We do see this on some cultivars in New Guineas. I threw it in. Just that high light leaf curl that we think what's going on with this plant. Some of it's cultivar specific, so you might need to modify some of your cultivars that you have. The next one, looking at copper deficiency, I threw it in. It is the case, but have I ever seen copper deficiency in a greenhouse? I mean, we induce this. You probably aren't going to run into it very often. The next one going on is e-GRs, insect growth regulators. This is from a research project that got nailed. They had some judo applied to it, and we saw basically this type of a meltdown occurring on the plant. Here's more of a close-up. And it was 100% across the board. So some of these e-GRs can be problematic. You can, I mean, you look at it, you might think that with that new growth that you had broad mites, you had something else going on. That this was hard to figure out because this was in our greenhouse. And so we finally went back and looked at the pesticide records, and that was the only answer for what was going on. And it's not just lobulary with judo, contos. You're not supposed to put it on geraniums. You get too high of a level, you get that cupping that's occurring, some discoloration. Ethithon, so that's a PGR, high concentration, you can get that ginkgo type of leaf there on that geranium. And of course, distance would cause distorted growth, more in a leaf curl going on. It really looks kind of like a 2,4-D application. And so different people think, well, it's my PGR application. Well, it might be the fungicide application instead for what might be going on with these plants. So, what do you do? There's not a lot of options. You could cut them back. You could come back in with a growth promoter like Fresco or Fascination. Is the time long enough? Is it economically feasible, or do you just go ahead and throw them away and then take care of it at that point? So then the getting towards the end on distorted growth, fasciation, that is just the thickening of those, but the top growth, here it is with some cleome that was growing. I've seen it on a number of other crops. It could be a bacterial aster yellows type of a problem with caused by a phytoplasma, or it could just be genetic. And so discarding the plant is your option that you need to look at. And I think we're down to the last one, and that is the actual agrobacterium. You can see that kind of that gnarly cellular growth that occurs with that versus leafy gall, which is the plant, the geranium that's to the left. You can see that there's many leaves that have actually formed, and that's rhodococcus. So there you can get some distorted growth, and neither of those are plant growth regulator oriented problems. So we went through the steps looking at different problems and how to solve it. Hopefully that will give you a better idea of some of the situations that we're looking at for distorted growth that actually are not PGR induced, but there's other problems. So you got to get the background information together to help you on that diagnosis. So then when you try a corrective procedure, you are in fact taking care of the problem if you can, because again, a lot of the answers were throw the plants away, and that's kind of tough to take. So I do want to thank the research supporters that support our program at NC State University with plant material from Fine and Duman, or Duman and Improving Winners, PGR work with Fine. We've done some tobacco work. We get great soil from Oldcastle and SunGrow, and then financial support from the American Floral Endowment, the Horticulture Research Institute, and the Fred C. Klockner Foundation. So with that, thank you for attending. And I want to thank once again Fine Americas for sponsoring the webinar. And now I'll open it up for questions.